So the floor is yours. And thanks again. It's a big honor to welcome you on board.
Perfect. Thank you. All right. Happy to be here. And yeah, thank you everyone for making it. So let me just present my screen. We'll go from there. All right. Okay. So yeah, as David said, I'm head of integration here at Chainlink. I've been working with Chainlink for around 2 years now, mostly on expanding the Oracle ecosystem. We have the number of users and making sure the blockchain ecosystem built on Ethereum, mostly decentralized finance, can run in a secure manner. So I'll go into all of these details now. First, I want to go over what problem Chainlink is solving. Okay. Now, just so we have all the same context, I'll go over what smart contracts are. Okay. Smart contracts are a piece of code which is deployed on blockchains. It can be Ethereum, it can be Cardano, it can be Ethereum, it can be kind of BSC, it can be XDAI, Matic, like any blockchain which has smart contract capability. And basically what a smart contract does is it takes inputs, and for every input it has, it will have a deterministic output, okay? So whatever happens to a smart contract, given a certain set of inputs, it will always output the same result. Very simple. If you want to have, for instance, an example, let's say I have an option contract. Let's say I have a put on some kind of stock, right? If the put reaches the price that I have a bet on, right, the strike price, then my contract will automatically execute, and the output will be that the person who took the put on the option gets the money that he should get when the price reaches the strike price, okay? So basically, instead of using third parties like banks, firms you have to trust for financial assets, we can just have a smart contract which will always execute when it should, right? So when the contract should be resolved in your favor, it gets resolved without needing to wait for Goldman Sachs or another firm to kind of work through the details for a few days, and then you have also counterparty risk, all of this stuff, right? So a smart contract allows to have a peer-to-peer system between two parties and to resolve the transaction automatically without needing a third party to trust. That's basically it, okay? Now, smart contracts have a big problem, which is they are basically siloed, okay? They don't have access to data natively on the chain. So for instance, in the example I just gave for a put options, you need the price of the underlying asset, right? So let's say I took a put on gold, I need the price of gold on the chain. Now, Ethereum and other blockchains don't have a way to natively get the prices to their chain, okay? They don't have a way to get data. That's what Chainlink is solving. Chainlink is solving the data delivery aspect of how do I get real-world data points onto the blockchain so that smart contracts can really be smart and are able to resolve complex problems in a decentralized manner while getting reliable data, okay? So very simple example, just to illustrate this, basically Chainlink solves this problem where you can't access market data like Bloomberg, you can't access events data. Events data would be supply chain delivery, for instance, or weather data, or any other data points you're interested in for, let's say, insurance or global trade. And then the output problem, which is once I have received these inputs, how do I output some kind of information which will go to the real world? Meaning, let's say I have to do a payment through a smart contract and the counterparty wants to receive a bank payment instead of a crypto payment, right? Cryptos are volatile. The institutions aren't using crypto right now, mostly. So how do I resolve a smart contract in a way where I get the data needed to resolve the contract and then settle the payment through some kind of bank or retail payment method like PayPal or Swift, for bank payments, how do we bridge the real world to the smart contract world? That's basically what Chainlink is focusing on. Now, a few aspects which are important. First one is that if you have a decentralized computation platform like Ethereum, and by the way, just to make sure I'm not talking out of the blue here, everyone knows what Ethereum is, right? Or should I explain a bit more?
Yes, for me.
Okay, maybe.
Okay.
Yeah.
All right, let me go over it quickly. So Ethereum solves the problem of how do I put smart contracts on a blockchain to basically have more kind of more freedom for developers to start creating decentralized applications, right? So if I was to go over the chronology of blockchain, first you had Bitcoin, and Bitcoin was very good acting as a way of transferring assets from one person to another. So in this case, Bitcoin assets, that's what Bitcoin does well. It solves the double spending problem, and it allows people to easily transfer assets from one place to another. Okay. Now, one issue with Bitcoin came that a lot of people wanted to start coding stuff on top of Bitcoin, more complex financial applications, right? So I want to transfer money from one person to another based on a certain set of conditions. And this set of condition would be, let's say I receive the delivery of a package, then automatically I can send the money away, Bitcoin cannot do this, because if you want to start coding stuff on Bitcoin, you have to basically affect the L1. You have to affect the protocol layer. The whole protocol has to be changed, which is not very practical, obviously. So a lot of people try to resolve this problem, Mastercoin, NXT, back in the days. Then Ethereum came, right? And Ethereum, they made it very easy for people to deploy scripts on top of the blockchain, which would allow to code up complex financial applications in an easy way, where not only are you able to transfer assets, you're able to transfer them based on certain sets of conditions. And you're able to code up all of these financial applications, which you have today on Ethereum, which are called smart contracts. And this is what Ethereum is basically. It's a leading smart contract platform, which allows people to easily code up financial applications or any type of application on top of the chain without having to modify the protocol layer every time. Okay. I hope I did a good job at explaining this. It's been a while since.
Very concise. Thank you.
So, okay. Now you have this extremely decentralized piece of computation called Ethereum, right? Decentralized, there are nodes running everywhere. There are crypto economic guarantees where miners on the Ethereum blockchain are paid ETH every time they mine a block. They have a financial incentive, to be honest. You have all of this stuff. It runs perfectly. And then the issue we had was, okay, so we have this system. It's very robust. We have smart contracts deployed on them. We want to get data to smart contracts. Now, how do I get this data over to smart contracts, right? Because I know that whatever happens with the smart contract, if I get a certain set of inputs, I will get an output. And unlike in banks or financial institutions or the real world we have today, if I get a bad input, there is no way to reverse it. So let's say your bank transfers you the wrong sum of money, okay? Just a simple example. I should have gotten 1,000 euros, I get only 500, okay? Now, with banks, it's very easy. I write them, okay, I should have, you forgot 500, I give them some papers, they solve it. It's not the same with blockchains. With blockchain, if I get a transaction, it's not reversible. It's deterministic. That's a counterparty of not having any centralized party here. There is no bank or customer service you can call to reverse the transaction, you see? So what happens is that these inputs we're getting into the smart contract need to be super secured. They need to have the same security guarantees that you have as the computation layer. So this layer is the decentralized computation, because otherwise you could get bad input into the system. And then you don't have an end-to-end secure system, right? You have a very secure computation platform onto which you're feeding centralized data from one centralized node. And that's a bad system. It's basically not end-to-end secure. And if you get a bad input into the system, you can never reverse the transaction. You're basically stuck with a bad resolution. That obviously can be very bad if there are billions of dollars at stake, which today in DeFi there are, right? So yeah, that's the Oracle problem. We want to solve getting data onto smart contracts. We want to solve it in a secure way where we have as secure of an Oracle system as Ethereum and other blockchains are. So end-to-end secure system. Any questions here, or does it make sense? Perfect. Okay, so yeah, that's end-to-end reliability in the system, which you can see here in this diagram. So basically, you get in the middle, the decentralized computation platform, and then you get the Chainlink network at the start and at the end for the inputs and for the outputs. Okay, that's something that's end-to-end secure. So some properties of Chainlink, and then I go more into some basic examples of how we're solving this, practical examples which are live today and being used to secure billions in value. So, Chainlink is decentralized, which means instead of having one single Oracle node getting data to the chain, we have multiple ones. We have provably secure nodes. So, we have nodes which have been running for a long time, which have a lot of economic guarantees, which have a history of running infrastructure. So basically, you can trust that these nodes will do well. So some of the node operators we have, one of them is T-Systems, which is Dutch Telecom subsidiary, right? And Dutch Telecom is one of the biggest telecom in the world, right? So that's one of the node operators we have. I don't need to go into all of those. You get the idea. It's basically lots of properties which allow to get a more secure input sequence into the system and allow to get parity on security between the Oracle system and the blockchain system. Okay, and that's through high quality data, crypto economic security, which is node operators are getting paid to put data on the chain. They're getting paid in link. Defense in depth approach. I know it's not supposed to be super technical today, so I won't go into the defense in depth and all of the stuff. Let's move on.
No, but that's anyway. You can if you think you can explain a little bit more. Don't hesitate. Don't worry.
I don't think I can explain in an easy way. That's the issue.
Okay.
So, I mean, we can go over it in the questions if you guys want.
Exactly.
I'm happy
Absolutely.
to discuss it.
Thank you.
So that's what the end result should look like. Okay, you can see the difference here between what I was showing here and what I'm showing here, right? Basically, what we want is for any application that needs data to the chain, you want multiple data sources. So you want redundant data sources. So for instance, very simple, if I'm sourcing data for a crypto asset and I want to put this data on the chain, I'm not going to source the data from only one exchange, because if the exchange goes down or has an issue or has a bad value getting into it, then the price I'm putting to the chain is affected, right? That's why you use data aggregators. So, for people who are in crypto, a data aggregator, they would know is CoinMarketCap, CoinGecko. For people in the traditional world, famous data aggregators include Bloomberg, for instance, which aggregates data across all exchanges. So you see, we take multiple data aggregators, we send this data to a decentralized Oracle network, which is basically all the Chainlink nodes communicating with each other from the data they source off chain to getting a final result also off chain, and then sending this result to the blockchain, which can be Ethereum, it can be any of the blockchains you see on here. So that's it. But it's basically decentralized data, decentralized Oracle network, and you send this all of this kind of highly redundant data to a blockchain, which then can resolve the transaction with the data you gave it, right? So maybe you gave it a price, maybe you gave it weather data, maybe the weather data solves an insurance claim, maybe the price solves some kind of liquidation event or some kind of put. Obviously, all of these transactions are very high value, so you need very high security. And in blockchain, you achieve high security through decentralization and through redundancy. Okay, so that's the system we work towards. That's another illustration. I want you mostly to look at the bottom, which is basically the different sources you can get. So for market data, you can see the different sources we can use, crypto prices, and then APIs. That one is less important, the last one, but mostly for crypto prices and market data, those are the ones we mostly cover later on. So okay, that's another illustration. Okay, I mean, look, let's give an example which is more simple. Let's say, and that's something, by the way, which we've done. We've worked with companies which are working on insurance claims for farmers. And one of them is Arbol, another one is EtherRisk. The way it works is you have an insurance contract being put, right? And this insurance has a policy holder and someone insuring it. So usually it's going to be the insurance company, right? Now, you want to resolve the claim of the farmer in an automated way through smart contracts, okay? Let's say the insurance is based on weather data. Let's say, if the weather drops a certain amount, maybe it's bad for a tomato farmer or any other farmer. It basically allows farmers in the developing world to take protection against weather events through the use of blockchain, okay, and through the use of Chainlink and smart contracts. Because farmers currently, in Africa, in Asia, these institutions to offer insurance policies for weather data, like some kind of safety net for farmers if they start getting some very adversarial weather. These don't exist in the developing world, or maybe they exist, but they're very hard to get, right? So that's the way smart contracts can help people in the developing world, because then you don't need an institution, you don't need to fill up papers, you don't need to trust that the insurance claim will be processed, right? You trust the smart contract that's deployed on Ethereum, and you trust the Chainlink node sourcing data from multiple data points to get the input that's necessary to the resolution of the claim, okay? So here, in this context I'm showing, instead of the insurance policy holder, which could be, in any country in Africa or in Asia or even in Europe, but, I think it's less needed there. He can basically take a claim directly on chain with the smart contract on Ethereum, and this claim is fulfilled by the Chainlink nodes based on the insurance, based on the weather data, sorry. So if the weather data gets in an adversarial way, where basically the policy holder would start losing money, he would have an insurance which pays him out to protect against his downside, right? And that's something that's very difficult today in developing countries. And that's why the weather can affect so dramatically people in these countries. And that's a very simple example of how smart contracts can help make the world a better place by having really this democratization of services where it's a global thing. A smart contract doesn't care if you're in Africa or in Europe or in the US. Okay, you enter into a claim, you have the conditions, and then they get fulfilled.
Maybe one question, Johann, from Christophe. Who decides what kind of data is available on Chainlink? Maybe it's a case-by-case probably answer, no? Or for example, let's take this use case with the weather. Yeah, how did you decide what kind of information you make available?
Chainlink is a free market kind of thing, right? Where basically you have node operators, and these node operators are selling services to consumers. Here, the consumer is a smart contract creator. And just to be clear, the smart contract creator is not Chainlink, the one doing this insurance claim. It's someone who's building on top of Chainlink. And this someone is going to deploy this contract, and he's going to talk to node operators, and he's going to tell them, okay, guys, I need data from Open Weather and any other API he sees for weather data. And then the node operators, because they're getting paid, have a financial incentive to add this data to their system and to start feeding this data, you see? So Chainlink you can think of as a free market kind of entity where basically consumers and sellers, meaning smart contract creators and node operators, are transacting together to get data points onto the chain, you see? So it's not controlled by us, it's not controlled by anyone, it's controlled by two parties which are entering into a financial transaction to get data onto the chain.
The data? Who's the one who decides to put the data under which
the node operator?
The node operator. Okay.
Well, the node operator adds a request of the smart contract creator.
Okay.
Does this make sense? Or
yeah, that makes sense. And just another question, maybe a link to that. I heard of building smart contracts in Solidity, which is a kind of the programming language for Ethereum. But how? I mean, what is the user the user experience for building the smart contract? Is it something that an insurance company or other players can manipulate very easily, or is it something that is anyway needed to be coded, you know, or how is it deployed in terms of?
These smart contracts are on Ethereum, or they can be on Matic or XDAI or any other chain, right? So this would be in Solidity.
Okay.
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 Now, as far as I've seen many companies who are starting to mingle into smart contracts. You know, mostly kind of testing the water and stuff. But yeah, that's happening slowly for sure. And you know, I predict that in a few years, we should see more and more of this stuff, because objectively, it does solve a lot of problems for insurance companies as far as processing claims, as far as resolving claims, kind of settling them, you know. It's a big win for them in terms of cost and in terms of resources, you see?
So you mean that we're going to have like something which is much more user-friendly and not only coded oriented, because today is really coded now. For example, if the insurance company wants to change one criteria in the smart contract, one parameter, is it something quite easily done, or you need to get a programmer to you know, in Solidity to change the parameter?
Yeah, I mean, that's how smart contracts work, right? And here we're not changing anything. That's something that's working fine. Obviously, there we need some developers, but I mean, developers are very affordable compared to the prices they're paying for processing claims and settlements. So, you know, I don't think it would be such a big issue for these big companies we're discussing here, you know?
Okay, I see. Okay, and how do you certify that the programming of the seed contract is okay? How do you print flows? The smart contract, how do you certify that the programming of the smart, how do you validate the programming of a smart contract? I guess there's some audit, or it's a question.
Just on this part, to be clear, that's mostly on the Ethereum part, you know. Now, what happens in the industry right now is all of these smart contracts are open source, and smart contracts are being audited right now for applications on Ethereum. You know, you have multiple companies which are extremely experienced in auditing smart contracts for billions in value. So, you know, that wouldn't be a big problem. But, you know, that's kind of outside of the scope of Chainlink. You know, on our side, we provide the services on top of the smart contract. You see?
I see.
Perfect. So, yeah, let's move on now.
Yeah.
Oh, except if there is any other question.
No, just a question about open source data.
Oh, well, open source data.
Yeah, saying that the smart contract is open source, so everyone can check which sources of data has been used. Yeah. Is that not a problem?
Source of data. Go for it.
Yeah, my question is that, the smart contract is open source, so everyone can check which sources of data has been used by the smart contract and by the Oracle. So is that not a problem that if the data used is spoiled or a thing like that, the smart contract will automatically execute with garbage data in? So is there a way to verify the data before it's been used by the smart contract?
So off-chain Chainlink nodes can easily code up some kind of a reference check, where basically it's taking data from one source and it's checking it against 5 sources, let's say. And if the check is positive, then it puts the data on chain. And if it's not positive, you know, if there is a big deviation between the two, it doesn't put it. You know, that's a very custom operation, very easy to make. Now, and you know, that might be for another convo, but I think you need anyways to make sure that the data is known by everyone, the data source. Because if I'm a farmer and if I have money in this contract, I want to know the source of the data that's going to settle my claim. Otherwise, you know, I'm kind of in the dark. You know, that's a very opaque system otherwise. So it needs to be open, but it doesn't mean that because it's open, it will be corrupted. Far from that, you know? So yeah, makes sense. Good question. Okay, so let's move on. Maybe if you, by the way, did this answer your question or?
Yeah. No, that for me it's okay. If you have any other questions, don't hesitate, guys.
Perfect.
Thank you.
All right, awesome. Now, I'm just curious, how many people here know DeFi? All right, I start from the basics. Basically, DeFi is decentralized finance, right? The way it works is everything that you have in the financial world, you can code it up as a smart contract on Ethereum, okay? Now, I'll give a few examples. Lending and borrowing is one application. So if I go today to my bank and I want to borrow some money, I'm sure you guys have been through this. It's kind of a pain. You need to prove a lot of stuff. You need to do a lot of things to do this. It's a painful process. Anyways, we get the idea. It's not the greatest. Synthetic assets and derivatives. So that's a bit more complex, but basically in the trading realm, in the trading world today, some people are using stuff like perpetual contracts to, for instance, bet on the value of gold, of silver, of oil. You saw recently, 1 year ago when oil went to negative, that was perpetual contracts on oil, right? Which oil price dumped a lot and the price was -40 for oil. Then you have asset management. So, if you have money, you want this money to be managed automatically. So, that's another thing you can do with finance and obviously insurance, right? So all of these applications and many more can be coded up onto the blockchain, okay? All of these applications can allow for a more open financial system where instead of having what we had before with, what we still have today, unfortunately, but there is a lot of opacity in the financial world, right? And I don't know if anyone saw the Big Short movie, but it does, it does sum it up a lot, right? It was basically, and we can go over the reason of this happened, but in my view, transparency was a big one, right? Where you had a lot of opacity, where like people were putting all of this garbage into CDOs and no one was bothering to read the CDOs. It was super opaque. It was super, it was basically the players who knew and could play the market, and they knew what would happen because they knew what was in all of these toxic derivatives they were trading on the market. And then all of the small people didn't know. There was a big asymmetry of information, right? Some people had access to lots of info. Some others had access to no info. And that's how everything happened. Because believe me, the banks and all of this stuff, they knew what would happen, right? And it was mostly due to this asymmetry of information, right? I mean, if people had known before, most people wouldn't have gone over leveraged by taking mortgage and getting loans from the bank and then not being able to repay it, right? So what DeFi solves is this asymmetry of information. Everything is coded up on-chain, transparently. Everyone can see the code, it's open source, everyone can see the transactions. Nothing is hidden, right? The big players have the same amount of information available than the small players. And this is great when you start coding up lending, borrowing applications, future contracts, derivatives, all of this stuff in finance, which, can be obfuscated, can be played in the current world, cannot really be played in the same way in the Ethereum world. It's much more transparent, it's much more open, anyone can access it. So if I was to go over the history of DeFi, the way it kind of started was with Maker. I'll briefly explain Maker. What Maker does is, let's say I have some Ether. Okay, on my side, I have some Ether in my portfolio, and I want to take a loan against this Ether. I don't want to sell my Ether. Okay, I like Ether. I think it's going to go up, but I still want to take a loan to be able to live my daily life. So what I do is I put my Ether into Maker, and my collateral can be used to borrow some what they called Psi at the time. Psi was basically, it's basically a stable coin indexed to the US dollar. So it's worth $1 all the time. And what happens is I can put a loan, I can take a loan against my Ether and start, using this cryptocurrency Psi to maybe pay back some mortgage or to maybe go and do some shopping. Basically, you're able to take loans super easily with your assets on Ethereum without having to go through any banks, without having to go through any kind of KYC system. And anyone can do it. It's not only the people in the US or in Europe, it's people in Africa, it's people in Asia. So anywhere where the financial infrastructure is completely broken, which it really is in the developing world, anyone is at the same stage. Everyone can take a loan against their collateral and start using this loan. And to me, that's really the start of everything we're seeing today in DeFi. It's basically, it's kind of magical, right? Like we're used to everything being so complicated to take a loan. And here I just transact with a smart contract. No one asks me some details. I just have my money. I put my money into a protocol and I take a loan against it. You see, simple and secure and transparent. So that's how it started. Then we started seeing more and more protocols, compounds and protocols, DYDX, synthetics. It was 2018. I won't go over every protocol. I do invite you to check them out after this presentation, because there is a lot of stuff which is very interesting in my view. In 2019, we have even more DeFi. They started interacting between each other. So a simple example of interaction between DeFi protocols and the composability of DeFi is, let's say, synthetics. Okay. Now, what will happen with synthetics is what synthetics allows you to do, and I'll go more over it later. I can put some assets onto the synthetics platform, and I can mint what we call a derivative, okay, based on the assets I put on there. And this derivative can follow any asset I choose from the real world. So it can follow the price of gold, it can follow the price of silver, it can follow the price of stocks, equities, Tesla, whatever, you see? And then I could put this derivative into, let's say, Compound, which is a lending borrowing platform, and borrow against the derivatives that I just put onto Compound. I could borrow some stable coins with the synthetics gold that I just minted on synthetics, you see? So just one example of interactions you can have between all of these protocols. There are a ton of composability aspects which people are working on right now and which are already live. And it's really quite impressive to see all of these connections you can do. It's much more modular than what we have today in finance, right? Because today in finance, it's very hard to do anything new. You have to go through a ton of regulations, ton of processes. It's extremely complicated. And here, it's much, much easier, right? You just have to be a developer and to want to code and to learn. So yeah, we've already seen a boom in kind of new financial products being rolled out onto Ethereum mainly, but also other chains. In 2020, the kind of DeFi growth continued. We had what we call yield farming. Now, actually, I don't think I'll go too much into yield farming because it gets pretty deep. I would encourage you guys to check it out. It's basically protocols distributing rewards and incentives whenever you deposit onto them. So it's been it would be too long to describe here maybe, so let's keep it for now. But the important thing to know is that in 2020, decentralized finance went from maybe 200 million or 100 million years before in TVL to 30 billion TVL, which means TVL is called total value locked. It's basically how much value there is on DeFi protocols at any point in time. Today, this number is 140 billion, which means people have put $140 billion in protocols which allows them to loan, to borrow, to mint synthetic assets, to mint binary options, to do some future contracts, some perpetual contracts. So decentralized finance is really exploding with this value being locked on multiple different chains. Okay, so I have a few kind of vocabulary points here just to run the page. One of them is how collaterals work. So basically a collateral is I put money into a protocol and this money can then be used to borrow something. So that's a collateral. Collateralization ratio is I have my collateral and I have what I borrowed, and then I have a ratio between the two, okay? And the way it works with DeFi is I'm always over collateralized, which means I always have more collateral than I can borrow. You might have heard of fractional banking and this type of stuff. where basically banks are able to distribute more money than they have, and they need to own maybe 1/100 of reserve or 1/10, I don't know what crazy number it is today. But the way it works with DeFi is it's fully backed. So if I want to borrow, let's say $75, I need to have $100 of collateral into the system, okay? And the ratio between my loan and my borrowing amount is the collateralization ratio. And then the liquidation is basically when this ratio falls too low, okay? So I have much more debt than I have collateral, then I get liquidated, which means I lose my collateral and the debt is paid back by someone. This is to make sure that everything stays fully backed in DeFi. Any questions here? I know that's a lot of stuff. So if you have any questions, please don't hesitate.
It's okay for me. Maybe if you want to ask questions, guys, don't hesitate to mute to take out the mute. Seems okay.
Perfect. That's a good sign then, or a bad one. I don't know. So Chainlink price feeds. Okay, now the way it works in DeFi is we have to supply data to all of these protocols, which are kind of allowing for borrowing, for lending. Because if I'm going to put some Ether into a protocol, the protocol needs to know the price of Ether in a reliable way, right? So the way it will work is I have what I call price feeds, what we call price feeds, which are what we discussed last time. It's a decentralized network of nodes. You can see all of the nodes here. Those are basically logos of random operators for just one price feed, okay? And this price feed has 31 oracles. And what these 31 oracles are doing is they're getting data for the price of Ether, and they're aggregating this data by taking the median. And then the median becomes the answer from all of these, well, the trusted answer, sorry, is the median from all of these oracles, okay? And this trusted answer is what is being fed to DeFi protocols to determine the price of Ether, you see? So an easy example. Okay, here I basically go into what I discussed last time, a bit earlier. DeFi protocols have this on-chain part, which is the smart contract part, and they have the off-chain part, which is all the data, okay? And yeah, if you want an end-to-end reliable system, you need to make sure the off-chain is as secure as the on-chain. You need to feed very reliable prices to make sure the on-chain execution is working right, has the right inputs to provide the right output, okay? So very simple example. I'm just showing here how it would work for synthetic assets, right? That's a workflow. Basically, the way it works very simply is a user deposits a collateral into his account, okay? This collateral can be SNX, which is a token. It can be Ether, it can be Bitcoin, whatever. We deposit this collateral. Based on the collateral deposited, the user can then mint an asset, and this asset will be pegged to any synthetic asset of its choosing. So it can be gold, to any real world asset, sorry. So it can be gold, it can be silver, it can be equities with Tesla. And all of this stuff is determined by the price oracle. And the price oracle is what I showed here. It's basically this price feed, you see? So here you can see the workflow. So basically the minting is determined by the collateral value. And then the synthetic asset is also determined by the price feed, sorry. And every time you need the value of these assets, you need the price oracle. So you need the price oracle to tell you what the price of gold is, and you need the price oracle to tell you what the price of the collateral is. Okay. And if the collateralization ratio falls, so if the price of gold goes way too up compared to the collateral you have, or your collateral goes down in value, then you can get liquidated, you see, because the collateralization ratio fell too low, you see. So that's how price feeds are being used today. They're being used to mint synthetic assets, but also to borrow assets, to lend assets. I have a few examples here. Today, the values that our price feeds are securing is around $25 billion in value in the decentralized finance world. So it's basically, we have around 300 reference price contracts deployed. So price feeds, which gives the price of Ether, of gold, of silver, of equities. And we have around 170 applications using Chainlink price feeds, you see? And basically the applications range from synthetic assets to lending and borrowing with AV, BZX Stream, to asset management, and to automated market maker, okay? I won't go over all of these. I would recommend people to read up on AMMs, automated market makers. They're very interesting. I think lending and borrowing and synthetic assets I kind of covered already. But yeah, you basically get to realize that everything in DeFi, in this new financial world which is being created, has to rely on price feeds. It has to have reliable prices to be able to work properly. Otherwise, it's like a bank that cannot get the value of the assets, right? So let's say the bank is assessing the value of your real estate, and to determine how much they can give you in a loan, they need to know the value of the real estate, and that's the oracle price, right? Now, in the traditional world, you don't need oracles because everything is happening off-chain, off the blockchain. However, in the crypto world, you need these prices. You need the oracles to get you all of this important data to know how much you can loan, how much you can borrow, all of this. So yeah, that's the idea here. I want to emphasize also that data can take many forms. On our side, we've, for instance, published presidential election results for the US a few months ago. We're currently putting stock prices on chain, so Tesla equities. We can put sport events results, so who won a certain match, and then people can create markets with smart contracts to say, okay, on an NBA match, this is a winning team, and the input will be the oracle data. We can put commodities prices, coin, silver, oil, and weather data for insurance. So, there is a lot of stuff we can do with oracles, and a lot of stuff that can be created based on this. Let's see.
Maybe one question about from Jean-Philippe. How do you evaluate ROI using smart contract in DeFi versus traditional scheme? Maybe Jean-Philippe, could you elaborate your question? Or you can answer if you want, if you hadn't understood the question, maybe Johann?
I kind of get it, but in my view, and maybe Jean-Philippe, you can clarify here, like the ROI is just a return on investment for whoever created the synthetic assets or created the option and kind of took a financial position in any of these items, right? So the ROI would just be how much he made out of his trade, except if I'm missing something here.
Jean-Philippe? Are you here, Jean-Philippe, maybe? You can, you need maybe me to reactivate your mic?
Yeah. Okay, is it
that's
better?
okay. Yeah, perfect.
Better when you have the mic on. Okay, so yeah, traditional ways, like you said, involves, people, it's kind of opaque. You don't know who really the process and those kind of stuff. We can understand that using through DeFi, it would be more seamless, easier in kinds of, the process will be probably less costly as well. Now the question is, we see that it involves a lot of different, technologies. The one from the database, they are costly. The programming is costly. So at the end, you end up also with, let's say a device that has a cost. So how do you, what would be, the fees like over a transaction? Is it 10%, 20%? How do you evaluate this? How do you sell it?
Yeah, so that's based on every protocol, right? So basically protocols, they deploy their smart contracts. Now keep in mind, a lot of protocols like AV and stuff, they have their own token, right? And the more people use their application, the more their token goes up in value because the more revenue their protocol generates, okay? Now, the users have to pay, to be honest, the biggest payment right now, which is happening on smart contracts is gas prices. they're very heavy on Ethereum. So basically, Ethereum, to use it, you need to pay gas every time you want to use a protocol. And this gas can be very expensive, you see? However, right now, I mean, as far as people using this stuff, you know, it hasn't really been a blocker because it's so much more easier for people to use, right? And the biggest telling point you can have is the value currently secured in this contract, 114 billion. Now, on my side, I don't know how people evaluate this compared to traditional finance, but you know, based on how easy it is to access, how easy it is to use, and how cheap it is to use also, right? I mean, I can tell you, you can take a loan for very cheap amount. You have to pay some interest, obviously, because the interest is determined by the interest rate between how much is supplied in the protocol and how much is being borrowed, right? But it's been pretty kind of, it hasn't been an issue for people to start using these protocols. Yeah, I'm not too sure what kind of answer you expect on this side. I mean, does it answer your question? Like basically to me, if the market is popping, right, and if people are using it, and if you have new applications every day, I mean, the laws of free market basically tell you that it's worth it. I mean, otherwise no one would do it, you know, if the ROI was not there.
Yeah, I understand what you mean. Probably now it's because I don't know. It's people jump on it because it's brand new, and you know it gives them a competitive advantage. And by the end, you know, 3 years down the road, there will be a lot of competition in the market. So what kind of competitive advantage one smart contract will bring versus another one? Is it cost? Is it what will be the parameters?
Exactly, that's a very good question. Look, on my side, what I'm seeing, and just to be clear, competition, I think we're on the same page, right? I thought we were discussing competition with a traditional word.
Yeah, of course.
But obviously, I mean, I hope you've seen from my presentation the benefits you have from smart contracts. Now, there is definitely competition already, right? Like for instance, lending and borrowing, you have 4 different alternatives, which are pretty big, 5 even in the space. Synthetic assets, you have, you know, a bunch of them, you have maybe 10. Competition is very healthy, just to be clear. You know, it's something we want to have anyways. So right now, I would say the way users can determine this is based on, at least for me, what I've seen, you know, some lending market might have better borrowing rates than another. You know, someone offers you better interest rates to lend money there than another one. You see, so it's mainly based on how much you have to pay, how much you're making, right? And also people take security into account. So for instance, if I prefer a security feature from a lending protocol to another, then I will probably use this lending protocol. Maybe it's using another programming language. Maybe it's using Viper instead of Solidity. Maybe it has better audits. You know, it was audited by more reputable companies, you see? So yeah, it's based on security. How much do you trust this company? Like how much, not this company, but this contract, like how much money are we willing to put on the line for it, right? And what is giving you the better revenue? What is giving you the better ROI, basically, right? So yeah, that's different factors. Obviously, there are more. You know, how many assets can you borrow on one? How many assets can you lend on one? You know, how active is the community? Can I take part in this community? Like you have a lot of different factors. But yeah, what I trust and the way I'm looking at things right now is that there isn't going to be one to rule them all. I think it's going to be very hard for any smart contract in any domain, whether it's derivatives or lending. It's going to be very hard for one protocol to take the whole market, you know, because it's so easy to create a competitor. It's a free market, right? Anyone can launch something, anyone can start competing. It's going to be very hard for anyone to attain a state where it's basically some kind of monopoly, right? I think in the crypto market, it's the barriers to launching something are very low. In the traditional world, you have all the regulation, you have all the stuff, you know, which you have to go through. So it's very hard for a new player to come to compete with Amazon, for instance, right? I mean, all the stuff you have to do, the regulations, the payments you have to take, you have to pay minimum wage, you know, that's a lot of stuff. it's very hard to launch new competitors, except if you're funded by Wall Street, and then you can go ahead. But here, in this world we have in crypto, anyone can launch something. Anyone can deploy on Ethereum. Anyone can start posting on GitHub. Anyone can create their community, their token. So yeah, I do foresee that this space is going to be ultra competitive, which is going to be a very, very good thing for innovation.
Okay.
Does this answer your question, more or less?
Yeah, it opens up a very interesting conversation, and thanks for the tips.
Perfect, absolutely, my pleasure.
Thank you, Jean-Philippe. Maybe another, if we can ask another question, Johann, is it okay?
Yeah, go for it.
Christophe, if you want to go on to ask a question. Christophe Figueras, maybe?
Yes. Okay, I just wanted to know, you told us that there is a lot of nodes, but for the same kind of data, if all the nodes are getting the data from the same provider, at the end, it is the same data. So it's just better because we know that the system is always okay, even if a server is down, no problem with this. But is there any way to get the data from different providers?
Yeah, absolutely.
Okay.
Very good question. Yeah. So obviously you want to minimize having only one data provider. Having 31 nodes for one data provider. It makes sense for the uptime. You have three things, right? You have data quality, you have uptime, and you have the possibility of corrupting the data with the nodes, right? How possible is it that the nodes collude and corrupt the data? Now, uptime is solved by having more node operators. Data corruption is also worked on by having more node operators. So the more nodes you have, the harder it is for them to collude. Data quality is solved by more data providers, you see? So on our price feeds right now, let me just go back. On our price feeds, every node operator you see is taking data from 3 different data providers off-chain, and they're taking the median.
Oh, we cannot hear you.
Which takes the median from all the nodes. Oh. Sorry, guys, 2 seconds. Yeah, all good? Yeah, my phone just triggers earphones to put the phone
okay.
sound,
No problem.
It's a Bluetooth earphone. So I don't know where I got cut off, so I'll restart. The node operators are taking data from 3 different data providers, okay? And they take the median from these 3. And then all of the node operators combine their data from the different providers they took, and then the network aggregates the median from the 31 operators you see here. You see? So basically, you have 2 levels of aggregations. You have 7 different data providers on the network, 3 per node, and then the 3 per node are medianized at the node level, and then all of the answers from all the nodes are medianized at the network level. You see? So we have extreme aggregation, like extreme redundancy on the data provider layer by having 7 providers at least. Some networks go up to 9 providers,
So does it mean that this work, if you, let's say, if you try to define a smart contract for some sport gaming or bet or something like this, it's okay because you will have a lot of providers. But in case, let's say we go back into my domain in the aviation, and you want to define a smart contract based on the delays of the flights. So basically, you have very, very few providers of data. So does it mean that because if we don't have at least 3 providers, are we able to define a smart contract anyway? Or
oh yeah, of course. But that's an agreement between the consumer, like the person using the smart contract, and the seller, the node operator. So if the node operator tells you, okay, we only have 1 provider, unfortunately we can't have more, then the consumer decides, is it worth the risk?
okay.
What kind of risk am I getting into? If you're securing $1 billion in value, I wouldn't recommend using 1 data provider, because if the data provider switches on you and he can basically screw the consumer, it wouldn't be good. However, if you're securing $5 or $500, 1 provider, who cares? Like the provider isn't going to ruin his reputation for $500, hopefully. So, then it's fine. So it's basically a risk reward, right? How much are you securing? What is the risk? And then you decide how many data providers. It's not fixed anywhere. It's not a fixed point. It's very modular. Yeah.
Okay, thanks.
Perfect. Yeah. Good question. All right, awesome. I think I have one last slide. Yeah, so I wanted to show one last thing, which is how Chainlink nodes can also be used for a very common use case, which is proof of reserve. Okay. So proof of reserve, what does it do? It's basically, I have, I don't know if anyone is familiar with WBTC on Ethereum, or anyone not familiar.
The wrapped BTC, yeah. But maybe you can explain a little bit, yeah.
Yeah, absolutely. So wrapped Bitcoin is basically a way for people holding Bitcoin to access decentralized finance on Ethereum. The way it works is Bitcoin is held in BitGo. BitGo is a custodian based in the US, and they issue a WBTC token to be used in DeFi. Okay. Now, one of the issues DeFi applications have is, how do I know that there is no fractional reserve going on? How do I know that every WBTC issued on Ethereum is backed by a Bitcoin owned by BitGo, right? In the custody of BitGo. So what Chainlink does is our node operators are able to fetch all of the Bitcoin data on the Bitcoin chain, which is how many Bitcoin does BitGo hold in its addresses on the chain, right? It's fully transparent, it's fully open, so we can read this data. And then we can put this data on Ethereum. And we're able to tell DeFi applications, okay, this is how much Bitcoin is held by BitGo in its custody. And smart contracts can then read this value and can then be sure that the WBTC is being properly backed by Bitcoin held in BitGo's custody. You see, that's one thing we've been doing, which I'm extremely excited about. It basically means that you can bring custodial assets to Ethereum, and DeFi applications can start auditing the reserves on there, basically. And we're able to do this also with stuff like TUSD, PAX, PAXG. It's a bit different because here we're taking the data from an auditor, okay? So basically the auditor, and TUSD also very quickly, TUSD, the way it works is similar to WBTC, but with dollars. So basically a company has some dollars in their bank account and they're able to issue a token called TUSD, which is the ownership of this dollar on Ethereum, okay? And what Chainlink does is also we ping, like our node operators are able to ping the auditor for TUSD, so the person auditing the reserves, and we're able to say, okay, this is how much is held in your TUSD's bank account to make sure that it's fully backed, okay? So yeah, that's proof of reserve. I think it's a big thing for the space, and it just shows you how modular Chainlink nodes can be, right? It can bring data from the real world, it can bring data from other chains, it can do all of this stuff basically. And all of this improves the transparency and the automation in DeFi, because what could happen is that DeFi protocols could put a circuit breaker if they see that any of these tokens is being under collateralized based on Chainlink node operators values. All right, any questions here? I see that there are a bunch of questions. Okay, I see. All right, wait, just 2 seconds, because I have some issues with my slides. Okay, 2 seconds.
Christoph says, yeah, it should have been used for Tether.
Yeah, right. I saw. All right, so yeah, and very quickly, the last slide, I think we're almost there. So Chainlink Keepers, that's another thing we're releasing with Chainlink is the ability for Chainlink nodes to do smart contract maintenance. So as you may know, smart contracts need to be triggered to do certain things like, liquidating contracts or doing limit orders or rebalancing or harvesting rewards. All of this stuff can be done by Chainlink nodes, monitoring these contracts and automating the transactions at the contract level. I won't go too much into it. I think it gets more technical here and it might be a bit too long, but yeah, that's basically my presentation. I hope it covered, the essentials. My view is that DeFi is hugely important. it's a paradigm shift in the world. I think it's one in a lifetime kind of thing where basically something as big as finance is being reworked, is being rediscovered, is being kind of remade, right? And basically DeFi is a whole new frontier, in innovation, in what we can do, in the possibility of basically this new financial system being created, right? And the exciting thing is that it's all new. It's very new. The frontier is moving every day, you see? So yeah, I think it's definitely worth it to start learning more about it, to learning more about the technology, the capabilities, the potential. All of this stuff is likely going to change the world. And, I think it's an extremely exciting thing that's popping up. And, as you may see, Chainlink is doing what we can to support the growth by providing the tools for all of these builders to build the financial world of tomorrow. Yeah. So I'll take some questions now if you still have time, and we can go from there. Okay.
So if you have some questions, ladies and gentlemen, open the question. Maybe one question about the comment. If you could comment what we read today, with block fee. I read that there was a mistake of block fee, giving away 720 Bitcoin instead of. I don't know if you had time to read it. There was a mistake.
Yeah, I see where you're going, but this one is a bit different.
Okay. Oh.
Yeah, that just BlockFi is a centralized service, right? So it's basically it's kind of a crypto bank. Here it's not really smart contract based. So for us, we don't really have an opinion. It's basically some mistakes that happened.
Okay, I believe there was a smart contract. Okay, I understand. Thank you.
Okay.
This is the perfect good example, counter example of the smart contracts. Thank you.
Okay. Perfect.
What else could we have? Do you have any questions, or do you want us to close the talk now? No, I mean maybe one question about Chainlink 2.0. There was a can you tell us a little bit about the version 2? That was
yeah, so we have a big white paper which is about 126 pages, so it's a big read. We had some very smart people write it, so I recommend people to look at it. Look, the biggest thing is really how crypto economic incentives are going to work, how the kind of staking system will work, how we're doing stuff like DECO. So, I think it might be a bit too long for me to be able to summarize it in this talk. However, it's basically the vision we outlined for the next few years to build something even more robust and, which can fit trillions of dollars in security on the network. Yeah.
And you talk quite a lot also about insurance. We have the DeFi application, which is the very trendy one today, and the biggest use case and concrete one that we are using today. What about the insurance? What is your vision about insurance use case, and when will it be? Even if you're not. I mean, what is your vision about it?
Yeah, definitely. So insurance obviously is something that's very key for many people, right? It allows them to still be able to have a work and be able to put food on the table in case of unpredictable events. So weather, some kind of catastrophic atmospheric thing, right? Like a tornado or something like this. Obviously, as I discussed, insurance is not available in every country out there. It's mostly in the Western world where we're lucky to have the right infrastructure. I think there is a lot to be done to bring what we have created in the Western world over to Asia, over to Europe, over to Africa, sorry, all of this stuff where basically people could access these contracts and cover their downside and the risks by taking insurance directly on the chain, directly through smart contracts, without needing to go to some kind of third party, which would charge them a lot of money and which would maybe act maliciously, you see? So yeah, obviously I'm extremely excited about insurance. I think it's going to be very big for the developing world to have insurance be enabled onto blockchain, yeah.
Great. Okay. I think we can close the discussion. I would like to thank you very much, Johann, for your presentation. Very interesting presentation, all your insights, and it was a big honor to welcome Chainlink and you today with Blockchain at HEC. So thank you again.